Hey everybody, Mr. Judson here. So one of the things that's real typical with calculus is we learn something new, like limits, and then the very next day we apply it to trig. So we'll learn something, we'll apply it to just normal functions, and then the next day we take that new idea and we apply it to trig. And that'll just keep on happening over and over and over again. We learn how to take a derivative. As soon as we do that, we learn how to do it with trig. And we got special rules within derivatives, like a product rule or a quotient rule. And as soon as we learn that rule, we do it with trig. So that's going to keep on happening. So one of the things we want to take a look at today is doing limits with trig. We're also going to mix something else in here with some piecewise functions that we didn't talk about yesterday. So let me get you guys a sample problem. All right, so here's a piecewise function, and it's got three pieces to it. F of x equals x squared when your x values are less than or equal to 2. It equals this middle piece, 8 minus 2x, whenever x is between 2 and 4, including 4. And anytime we're larger than 4, f of x just equals 4. Okay? We graphed some of these last year. You know, you would graph part of a parabola, but only show the values where x is less than or equal to 2. And then once you get between 2 and 4, you'd switch over to a linear equation. And once you get larger than 4, it just becomes a horizontal line at y equals 4. What we want to do is we want to find the limit as x approaches 2 of f of x. You guys go ahead and try it. All right, so the thing that's really important to remember here is I got to make sure I get on both sides of 2. All right? And so when I look at this, when I'm less than 2, I'm plugging into this equation. If I'm slightly larger than 2, I plug into this equation. Now, one thing that's a little bit different with this is it is defined at 2. Right? F of 2, I plug a 2 in here and just get 4. But that's not the question it's asking. It's saying, what are the y values getting close to as x gets close to 2? So I'm going to make an xy table. I'm going to plug in a number slightly less than 2, so 1.999. And so if I plug that in, since that's less than 2, I have to plug it into here. So I want to do 1.999 squared. Okay, let me grab my calculator. All right, so I'm going to square that. And so I've got, let me get back to my home screen, F18, clear that off. I've got 1.999 squared. And the answer I get is 3.996. And then if I plug in a number slightly larger than 2, 2.001. Now since I'm in this range of values, I've got to plug it into this piece. So again, I'll go back to the calculator. I've got 8 minus 2 times 2.001. And I get 3.998. So I would look at those and think to myself, now, this is kind of weird because you look at that and you'd go, well, a number between these would be 3.997, so it must be getting close to that. But I look at it and I go, no, these are both getting close to 4. And so that's the answer to this problem. Now, why didn't we choose a number that's between these two? Well, if you look at the graph, so here's my piecewise function, and anything less than 2, I've got a parabola. So it's probably going to look something like this, but it stops right there. And then here I've got a linear equation. It's got a negative slope. It's got 8 as a y-intercept. My guess is it probably is going to go down, let's see, it's probably going to go down something like this. I don't know exactly to where because I'm just trying to get a general graph. And then all of a sudden, let me just think here for a second. Then all of a sudden we've got y equals 4 from this point on. So if this right here was 4, let's see, I'm going to have an open circle here, and then the graph turns into a horizontal line. I think at 4, if I plug it in, I get 0. So this piece really should do that. There's what that graph looks like. So yeah, these numbers are both less than 4 because we're kind of at a point right there. And so we're getting larger, 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 closer to 4. On this side, we're getting larger, 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 close to 4. On both sides of x equals 2, we're getting close to a y value of 4. Now, if this problem would have said, find the limit as x approaches 4 of f of x, well, if I look at this graph, on one side of 4, we're going down and getting really close to y equals 0. On the other side, it's y equals 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. 0 and 4 aren't close to the same thing. And so we would say this limit does not exist. Okay? So we're going to see some things today with piecewise functions. Here's another problem. So the limit as x approaches 2 of x squared plus 4x minus 3. So one of the things that makes this different than what we did yesterday is there's no fraction here. I don't have to worry about plugging 2 into the denominator and getting 0. And so when this happens, we have what we call direct substitution. And what it means is I'm just going to take that number and just substitute it right in there. I'm just going to plug it in. It's just like saying if this is f of x, what's f of 2? So my answer is 4 plus 8 minus 3, and that's going to equal 9. When you look at this, this is a parabola. It's not undefined anywhere. And so what happens when x gets close to 2? My y values get close to 9. Okay, it gets really close to that point 2 comma 9. Direct substitution doesn't happen very often, but it does occasionally. And if I can just plug a number straight in there and get an answer, then I want to do that. Most of the stuff we did yesterday, if you plugged the number straight in, you got 0 in the denominator, and it's undefined, which means you can't do direct substitution. Okay? If we go back up to the previous problem, I'm trying to find the limit as x approaches 2. There's no fractions here, so it is defined. If I plug a 2 straight into here, 2 squared is 4. If I put a 2 into here, I get 8 minus 4, which is 4. Since I got the same answer for both, that is the answer to the problem. So I could have solved this with direct substitution. All right, let's try something with some trig. All right, so one thing I just want to say real quick. Last semester in the spring when we were doing trig, that's when the whole COVID thing hit. And some of you guys might be a little nervous about trig, and you might wonder, geez, do I know enough trig? Trust what we learned, okay? I made sure that we would know enough to be successful this year in calculus. And so as long as you did the work and stayed on top of things, then you should have a good trig background. You should be fine, okay? One thing that we want to remember is we do not work with degrees in calculus. We only work in radians. And so when we see a limit and it says x approaches 0 or pi over 4 or pi over 3, something like that, just remember we're always dealing with radian measures. Okay? If we go back and think of our unit circle, here's our unit circle. We put 5 tick marks in every quadrant, right? And we said we're going to count by twelfths. So 1/12, 2/12, 3/12, 4, 5, 6, 7, 8/12 right here. 8/12 reduces down to 2/3. So this angle would be 2 pi over 3. And as long as you remember that, I think you're fine with anything that we do here today. Pi over 2, pi, 2 pi. This one is 3 pi over 2. You may want to go back and look at your notes from last year on the unit circle, because we'll refer to it a lot. If not, if you just Google unit circle, there's all kinds of images on the internet, and good ones. I got this unit circle off the internet. It's got everything that we talked about. It doesn't have the 5 tick marks, because if you remember, these two, we didn't have coordinates for them, but we know they're there, right? So this is a common one. I think it's in our book. We don't have a hardback book. It's usually inside the front cover of our book. So maybe take a look. Let's look and see if it's there for that as well. All right. So let me just back up here. All right. So we want to go ahead and try and solve this limit. You guys give it a shot. So I'm still doing the same thing. I'm going to plug in a number that's slightly less than 0, so a negative 0.001 and 0.001. I know at 0, sine of 0, so again, remember our unit circle. This is the point 1, 0. Cosine goes with the x coordinate, sine goes with the y coordinate. So the sine of 0 is 0. That means I got 0 in the denominator, and that's undefined. So I'm just going to take my calculator and plug these two things in. I just want to make sure that I am in radian mode. So let me just double check this calculator. If I hit the mode button, yes, I am in radians. Okay, 4th item down. You want to check yours as well. Keep it in radians. But I know as I say that, you guys will use this calculator for your science classes, and you will have to put it in degree mode now and then. Just make sure you convert back to radians for this one. All right, so I'm good. And I'm going to clear this off. So I want to do, in parentheses, 1 minus the cosine of this angle. Cosine of a negative 0.001. Close parenthesis for the cosine, and then close for the numerator. And then divided by the sine of a negative 0.001. Hit enter. So we haven't seen this yet, but we saw this on our calculator last year. It means we're in scientific notation, so this is negative 5.0000, so on, times 10 to the negative 4th. It means I've got to move the decimal point this direction 4 places. So this is really a negative 0.0005. So a negative 0.0005. And now I'll do the same thing here. So I just need to take the negative sign out. All right, so now I have a positive 0.0005. And so when I look at those two numbers, those are pretty close to 0. There's my limit. If you want to graph it, just to have a look at it, probably not a bad idea. So if I go up here, we're going to clear that. I've got, in parentheses, 1 minus the cosine of x. Close the angle, close the numerator, and then divided by the sine of x. And so let's see, if I'm graphing in radians, now really all I care about is what's happening at 0. And I got a y value 0, so I just need to see the origin. So let me see if this works. Yeah. So as we get close to x equals 0, our y values are coming down and getting close to y equals 0. This almost looks like a tangent curve or something. Does that mean this is equal to a tangent? Remember the simplifying trig expressions? All right, so there it is. That confirms my answer graphically. All right, let's try another one. Oh yeah, now we're getting to some good stuff. I like it. This just looks ugly, right? So this time our variable is delta x, and we want the limit as delta x gets close to 0, which means we got 0 in the denominator again. Cosine of pi plus delta x, that whole thing plus 1, and then divided by delta x. Same as the previous one. I just want to plug in numbers close to 0, and I want to get on both sides of 0. So negative 0.001. If I plug in a 0, we are undefined. And then a positive 0.001. All right, so I'll grab my calculator. Back to the home screen. Remember that home button. And I'm going to do, I've got to put my whole numerator in parentheses. All right, so we know if we plug in a 0, it's undefined. If I plug in this value, I actually just did this on my calculator, but the battery on my video camera died, so it's already in here. When I plugged in a negative 0.001, I got a negative 4.9999999 e negative 4, which means if I move it back 4 places, I get a negative 0.00049, which I'm just going to call a negative 0.0005. And when I plugged in the positive value, I just got the same number but positive. So 0.0005. So again, those both look like they're getting close to 0. So that's what I think my limit is. And so there's my answer right there. This limit is getting close to 0. Looks the same as the previous problem, but obviously a different trig expression. Okay? I don't want you guys to think that everything we do in trig looks like this just because those two matched. They won't. They'll be different. All right. That's what we have for today. It's really no different than what we did last week. It's just that we're plugging numbers into trig expressions or doing piecewise functions. So you guys should feel like this isn't too bad. All right, let me get you guys an assignment. All right, so we're now starting number 4. It's our 4th week here. Page 59, we're going to do 9, 10, 17, 18, 27 to 30, and 32. So even though we're continuing with limits, it's not part of last week's assignment, okay? Assignment number 3. I know I'm not here to answer questions for you guys. Let's go ahead and turn that in. So when I get back from my surgery, we'll make sure we still take care of questions and get things cleared up. But for now, let's just plan on turning things in on Tuesday because that's the schedule that we've set. All right? That's it. I'll see you guys. Hopefully I'll see you guys on Thursday. I should be good by then and ready to go. And so take care. I'll see you then. Bye.